Hello, math humans. We're going to do Chapter P, Section 1 today. This is a pre-calc review before we start calculus. So our objectives are that we're going to sketch graphs, find x and y intercepts, test for symmetry, find points of intersection, and just turn our brains back on after a long break. So as we talk about sketching graphs, there are a couple of different ways that you can do that. One is a table of values, and we don't do that much anymore because we're in big kid math, so you could fill in a table. We can find x and y intercepts, which are glorious. Remember that for an x-intercept, y is equal to 0, and for the y-intercept, x is equal to 0, so you would solve for the other variable and then connect the dots. Okay, if we're talking about intercepts, this is the point where a graph or a function, whichever you choose to say, crosses either axis. And if you will remember from pre-calc, when we report intercepts, we would report the x-intercept, and then I might write a number and then 0, and then for y-intercepts, I would write 0 and a number. So remember that reporting is very important. In calculus, it is even more important, so that you always want to make sure you report well. Our first example, and the examples are numbered so that if you have a question, you can specifically ask about the example. This one says, find the x and y intercept of y is equal to x cubed minus 4x. So for the x-intercept, that's when y is equal to 0. I'm going to get x cubed minus 4x is 0. I'm going to factor and get x squared minus 4. And I'm going to get x plus 2 and x minus 2. If you'll remember from our work in pre-calc, these little baby equations are my solutions. So my x-intercepts are going to be 0, 0, and then plus or minus 2, comma 0. Okay, so it's way okay to use plus or minus because then that just makes my writing easier. For the y-intercept, I let x equal 0, and I get, that's just really super simple, I get y is equal to 0. So then when I report, then I would have 0, 0. So that's actually super easy. A couple of things about reporting, and I'm going to harp on this all year because the difference between a 4 and a 5 on your AP exam is being able to have a conclusion statement at the end of your work. So you always want to have a conclusion statement at the end of your work. All right, the next topic, and we just fly through a bunch of different topics as we prepare for calculus, is talking about symmetry. And if you'll remember, when we talk about symmetry in math, we are interested in y-axis symmetry. So the classic example is a cute little parabola. I'm interested in x-axis symmetry, and that cute little example is the square root function. So this might be y is equal to x squared. This would be plus or minus the square root of x. Actually, I lied. Is that true? I think that's true. Y is equal to plus or minus the square root of x. And then the last type that we're interested in is about the origin. I have to get my brain turned back on as well. So maybe y is equal to x cubed, and that graph might look like this. So remember, when we talk about symmetry, the next thing that we're going to do is talk about our tests for symmetry. And really, there's only one test, so that S is kind of an oxymoron. So basically, when I test for symmetry, I want to run a negative x through the function, and then I want to see what happens. if I have f of a negative x and it equals the original function, meaning all of the signs are the same, so all signs are the same, and the function doesn't change, then this is symmetric about the y-axis. If, on the other hand, when I ran a negative x through the function, and all of the signs are the exact opposite, so all signs are opposite, then that means we are symmetric about the origin. Woo! All right, I'm going to have to go to another piece of paper. The easiest way to talk about x-axis symmetry is this. If I am solving for y and I get a plus or minus and then whatever my equation is, this is your key that it's potentially going to be symmetric about the axis because it's meeting the requirements for both the first and the second test, and so it satisfies both tests. All right, so the example 2 is going to say test for symmetry. And always when we test for symmetry, we're going to do this algebraically. And remember that the words algebraically, spelled it wrong. So if I test algebraically, that's the same thing as analytically. So those two words can be used interchangeably, whether I have algebraically or analytically. So I'm going to have the function y is equal to 2x cubed minus x, and I want to test for symmetry. So I'm going to run a negative x through the function. There's really only one test, and I'm going to get 2 times a negative x to the third minus a minus x. 3 negatives is negative, so this is a negative 2x cubed plus x. We compare it with the original function. In the original function, the 2x cubed was positive, now it's negative. The second term was negative, now it's positive. All of the signs have changed, so therefore we would say f of a negative x is equal to a negative f of x, and then we can say, I'm sorry, I was just looking at my math, and I think I'm right, that this is symmetric, I can't spell, about the origin. Alrighty, so that's actually pretty easy. But again, the mathematical justification is to show that you ran the number through the function and then see what happens. And then this would be my reporting. This is what happened when I did the math. And then this is my conclusion about the symmetry. All right, example number 3. We're just going to talk about graphing. Okay. So I want you to graph using intercepts. And if the directions say to graph using intercepts, that means that that work has to be shown on your paper. So if my first equation, or my only equation, is x minus y squared is equal to 1, and if I'm graphing using intercepts, the first thing that I want to do is find the x-intercept, which is when y is 0. And so I get x is equal to 1. That was easy. And so my x-intercept is going to be 1, 0. And then my y-intercept happens when x is equal to 0. So I'm going to get a negative y squared is equal to 1. Y squared is equal to a negative 1, which means that this is going to be y is equal to plus or minus the square root of a negative 1, which is plus or minus 1i. Because it is imaginary, there are no y-intercepts. Okay? Alrighty. So I can also try to graph. I found my x-intercept. I know it's going to cross at 1, but I'm also going to rewrite this equation to illustrate a point. So there's a negative y squared is a negative x. Y squared is going to be equal to x minus 1. Y is going to equal plus or minus. There's my hint about the symmetry, and then x minus 1. This is actually a really easy little graph. There's my x-intercept at 1. Plus or minus means that there is my cute little graph. Alrighty, I think that's it for those. All right, cruising right along to yet another new topic. We're going to talk about solutions of equations. And all of Chapter P is going to be like this. It's just a lot of what I would call the shotgun approach, lots of little snippets from pre-calc just to turn your brain back on about what happens. So the solutions of equations would be a system of equations is going to be the point or points of intersection. And remember, if you use a graph to solve a problem, you must sketch and label the graph. Because if the graph is your work, that work must be recorded. Because unlike pre-calc and calculus on your AP exams, you have to show the work, you also have to label your work as well as the answers. So we'll talk about that as the semester goes along. Alrighty, so let's do a next example. So our fourth example, and it's going to say solve the system. So I'm going to have x squared minus y is equal to 3, and x minus y is equal to 1. So we are going to actually add the additional caveat that I want you to do this by hand. A more appropriate term would have been analytically, which means you have to do some algebra. So basically what I'm going to do is I'm going to solve by substitution. I'm going to solve both equations for y, since this one's not linear. And I'm going to get a negative y is equal to 3 minus x squared, or y is x squared minus 3. The second equation, a negative y is 1 minus x, or y is equal to x minus 1. Both of the y's are equal, so I'm going to set them equal to each other, x minus 1. This is a quadratic. That means that everything needs to be on the left-hand side. So x squared minus x minus 3 plus 1 is 0. X squared minus x minus 2 is 0. Factoring is your favorite F word, so that means that we are going to solve this by factoring. So I get at x minus 2, x plus 1 is equal to 0, and I get x is equal to a negative 2, a positive 2, and a negative 1. Bad math. Alrighty. So, but the problem is, this says solve the system. Well, the system has x's and y's, so then I need to find the y's that correspond with these x's, and I'm going to use the second equation because it's easier. So if x is equal to 2, then y is equal to 2 minus 1, which is equal to 1. And so that ordered pair is going to be 2, 1. And then if x is equal to a negative 1, y is equal to a negative 1 minus 1, which is a negative 2. And that ordered pair is going to be a negative 1, negative 2. So then I would write that my solution to the system is going to be 2, 1, and negative 1, negative 2. That's a parentheses. Alrighty? So really pretty simple. I could also have done this graphically and looked for that point of intersection. So if we just think about that, let's stick it up here in the corner. So if I have y is equal to x squared minus 3, if this is a negative 3, that means that little graph looks like that. And then y is equal to x minus 1, so I would have this, and then I would have 2 points of intersection. And then I could have found those in my handy-dandy grapher. The last thing that we're going to do today is we're going to go back and remember how to do regression. Okay, so our last example, so example 5, I'm just going to walk you back through a regression problem. So we'll put regression up there. And if you'll remember, this is a long process, so I'm just going to walk you through this together. So in our data, we're going to have a year, and then this is going to be the number. And our data is going to represent the number of cell phone subscribers and it happens to be in millions. for selected years. So, and our data is really old because our book is really old. All right, and then I have 1993 and 16, 1996 and 44, 1999 and 86, and then 2002 and 141. It would be really interesting to see how the model compares to values today. And then time is equal to 0 is the year 1990. Alrighty, so if you will remember this process, the first thing that you want to check is we're going to go to our mode button, and we want to make sure that our diagnostics are on, and mine are not. So I'm going to go all the way down to diagnostics, and I'm going to hit on. I'm going to pull my calculator up here, but make it closer so you can see it. Nope, maybe not. All right, so our diagnostics are on, and then I'm going to quit. The next thing that I'm going to do is I'm going to go to my scatter plot, and I'm going to turn the first one on. Okay, and remember that the first box is your scatter plot. These are all the different options up to the box and whisker plots, but notice that my L1 and my L2 are talking about my X's and Y's. So then I'm going to quit. The next thing I'm going to do is going to go to my second memory, and I'm going to go to option number 4, and I'm going to clear my lists so that I can wipe them out. Now what I'm going to do is stat, edit, and I'm going to enter my data. Okay, so they told us that year 0 was 1990, so my first 0 is going to be, or sorry, my first X is going to be 0, and then I'm going to have a 3, 6, 9, 12, 15, and then I'm going to go to my Y values, my dependent variable, and I'm going to have 5, 16, 44, 86, 141, and 208. Okay, and if you need to, you can pause at any point or rewind to keep up with the steps. Remember that the next thing that we do is need to look at our data, so I'm going to do a zoom 9. Oops, and I still have an equation. I have a lot of equations. Stop! I'm going to go to my y equals and clear all that stuff, and I'm going to go back to my graph. There it is. And it would appear that my graph is quadratic. So now I'm going to find that quadratic model. So I'm going to do stat, calculate, and I'm going to go down to option number 5, which is quadratic. The only thing that's really nice about these, well, there's lots of things really nice about these calculators, but doing regression in these, I can tell my calculator to do alpha F4 and store my regression equation in Y1. Alrighty, and then I'm going to tell it to go. At this point, I would write this equation down. So I get y is equal to 0.770 x squared plus 2.090x plus 4.143. And then I'm going to write down that r squared is equal to 0.999854. And I'm going to need that in a moment. Okay. So now what I'm going to do, if I look at my y, there's the equation, I'm going to hit graph. And now my equation is going through my data points. It would appear that my regression is really good. Remember that from pre-calc, I need to take the square root of this because the correlation coefficient, ELAT, the correlation coefficient is r, not r squared. And remember, that shows you what percentage of the data points that your model goes through. So we'll take that value in a minute. And then let's say I want to predict what happens in 2015. Okay, so remember that 1990 was going to be year 0. So that means that we will do 1990 25. So our x is going to equal 25. I usually have to zoom out, so I'm going to do a zoom 3 enter. And there's more of the parabola. Second, calculate value. What happens when x is 25? And there's my answer. So I'm going to scoop my little grapher out of the way. So f of 25 is going to equal 537.556 million, million users, alrighty. And then if we go ahead and manage our correlation coefficients, I'm going to quit, and I'm going to do the square root of 0.999854, and I get that my correlation coefficient is 99.99%, so R is equal to 99.99%. My model is extremely good. All right, my dears, that is it for today. I will see you soon.